Okay, in this video we're going to be doing a crash course basically of matrices. Okay, and hopefully along the way I'm going to build up a little bit of intuition about why we use matrices and what they actually what role they play in maths. Because I remember when I first met matrices, I just learnt the rules. I learnt this is what you had to do, had no idea of why you were doing it. And I think that sometimes when you have kind of this understanding of what you're doing and why you're doing it, it really helps. If anything, just to make sense, and it sort of just makes sense of all these ideas that are floating around your head and just kind of consolidates them together. Okay, so what are matrices? Matrice C is the plural of matrix. Okay, well a matrix is just a table of numbers, and you can just say if you have all this information in front of you, all these numbers in front of you, they all mean something. They come from somewhere, and you want to do a big operation on all of these numbers. Well, rather than doing the operation on each individual number, put these numbers into a big table, a matrix, and then you can do the operation on that whole matrix all in one go. Okay, so it's much faster. That's the first advantage and first reason why we might want to use a matrix. Okay, so say if we have, first of all, let's start off with an ordinary number. Let's say 5. Well, we can represent this number as a matrix. There you go. It's a 1 by 1 matrix. Okay, not necessarily that useful because usually we just deal with, the number 5 on its own. We wouldn't necessarily deal with a 1 by 1 matrix. But the reason why I want to show you that is because this is actually a really useful way of building up your intuition. And I'll keep coming back to this a little bit, sort of a bit later on in the video. So this is a 1 by 1 matrix. What do I mean by that? I mean that's the dimension of the matrix. Okay, so a 1 by 1 matrix, 1 by 1 matrix, we write it like this. Okay, it means one row and one column. And it kind of makes sense that the row should come first. Okay, because when we deal with Cartesian coordinates, for example, let's say x, y, the row always comes before the column. Okay, so the across always comes first, then the up bit comes later. So row comes first, then the column. Okay, you may not necessarily be able to see it here, but say if I have 3, 2, 6, 4, okay, that would be a 2 by 2. Okay, because it's 2 rows and 2 columns. Right. Okay, so that's the 2 by 2. So now we've established that we can represent numbers as matrices. Well, we can perform operations, things like add, subtract, multiply, divide, on numbers. So why can't we do it on matrices as well? Well, we can, and I'll show you how. So let's first of all look at addition. So I've got these two matrices here. Let's first of all look at the dimensions of these matrices. This is it's a 2 rows, so 2, and then how many columns? 1, 2, 3, 3. So it's a 2 by 3 matrix. Okay, and this is exactly the same. Now with addition, it's crucial that these two matrices have to match in dimension, and the resulting matrix will also be of the same dimension. Why? Because when we add or when we subtract, we simply just add each number or each element. Remember, an element is just the number in each position in the matrix. So the 4 will be one element, the 2 will be another element, etc., etc. We just add each element together. So this is the first row, first column. We add that to the first row, first column of this matrix, and we put it in the first row, first column of this matrix. Okay, and so on and so on. So this is 4 plus 3, which is 7. This is 2 plus 12, which is 14. This is 6 plus 4, which is 10. This is 3 plus 7, which is also 10. 5 plus 16, that's 21. And 9 plus 20, that's 29. There you go. And if it was to subtract, we do exactly the same thing, except instead of adding these two numbers together, we subtract them. Okay, but it's exactly the same idea going on. And that actually brings us in really nicely into this thing called scalar multiplication. So say if I have this matrix here, but I want to multiply it by a scalar. Now remember, a scalar is just an ordinary number. Okay, it's a number with a value, but it hasn't necessarily got anything else associated with it. Remember, a vector, scalars and vectors go together. A vector is the value, but it also has a direction usually associated with it as well, a magnitude we call it. Some way of kind of distinguishing a direction. Whereas this is just a scalar because it's just an ordinary number. So say if we multiply this number 3 by this matrix, okay, well that's just the same as saying we want to add this matrix 3 times. Remember when we do, say if it was 2 times, I don't know, 4, okay, that's the same as saying we want to have 2 lots of 4, so we want to add 4 to itself twice. Okay, it's exactly the same thing with scalar multiplication. So it's this matrix added 3 times. Okay, I'm not going to write this out 3 times. It'll just take too long. Okay, oh no, actually I am. Just very quickly, 7, 14, 10, 10, 21, 29. Then we want to add that to the same thing. 7, 14, 10, 10, 21, 29. This got very messy, I do apologise. And then we want to add that again to 7, 14, 10, 10, 21, 29. You get the idea, okay? So what we're basically doing is 7 plus 7 plus 7. That's the same as doing 3 times 7. Okay, then 14 plus 14 plus 14. That's the same as doing 3 by 14. And then 10 plus 10 plus 10. That's the same as doing 3 times 10. Okay, and then 10 plus 10 plus 10. That's the same as doing 3 times 10. 21 plus 21 plus 21, that's the same as doing 3. Pen stop working. 3 times 21. Then we do 21 plus 29 plus 29, that's the same as doing 3 times 29. Okay, so you can see that with scalar multiplication, that's just the same as putting this 3 next to each and every element inside the matrix. So in other words, we can also take out a factor. So say if this was 21, if we had this written as 21, 3 times 14, which is 42, 30, 30, 63, and whatever that is, then we could spot, well, okay, well each element has a factor of 3, so then therefore we could also take out a 3 out the front. Really useful thing on the side. But that actually brings us on really nicely to this thing called ordinary multiplication, so multiplication of matrices. So say if we had an n by m matrix, that's the dimension of the matrix, an n by m matrix, and we want to multiply that by an m by p matrix. Okay. Well, in order to tell whether we could actually do that, these two numbers in here, the inner numbers, have to match. If they didn't match, we couldn't do the multiplication. Okay? And the dimension of the resulting matrix will be given by this outside, these outer two numbers. So I've got written down here 2 matrices that I want to multiply together. Okay, so what's the dimension of this matrix? Well, it's a 1, 2 by 3. Okay, and I'm multiplying that by it's a 3 by 2. Okay, well, I can do that multiplication because these inner two numbers match. And the resulting matrix will be a 2 by 3. It'll be given by these outer two numbers. So the resulting matrix will be 2 by 2. Sorry, I said 2 by 3. It's 2 by 2. Okay, that will be the resulting matrix. Now, here's where it gets a little bit weird, and I first met this and it didn't make any sense to me. It does kind of make sense if you think, right, row multiplied by column. Okay, so each element in the row multiplied together, and you add them by the column. Sorry, that didn't really make sense. Let me try that again. So each element in the row multiplied by the corresponding element in the column, and you add each of those multiplications together. So let me show you, actually, because I'm not entirely convinced that was a better explanation. So in this, so this is the resulting matrix. This is the resulting 2 by 2 matrix after we do this multiplication. Okay. In this element, well, this element is the first row, first column. So that tells me that I'm going to be looking at the first row of this matrix and the first column of this matrix. And I'm going to multiply the 6 by the 4, so the corresponding elements, so the 6 by the 4, which is the 24, and then 4 by 1, okay, so the corresponding second element, so 4 by 1 is 4, and then 2 by 2, and that's 4. And then I'm going to add them all together. So I'm doing this times this, plus this times this, plus this times this, effectively. Okay. Now I'm going to look at what's going to go in here. Well, this is the first row, second column. So I'm going to be looking at the first row of this matrix and the second column of this matrix. And I just do exactly the same thing. I'm going to multiply the corresponding elements together. So it's going to be 6 times 2, it's going to be 4 times 3, and it's going to be 2 times 5. And I'm going to add them all together. Okay, likewise, this is the second row, first column, so I'm going to be looking at the second row of this matrix and the first column of this matrix. So it's 3 times 4, 12 times 1, and 1 times 2. And I'm going to add them all together. Okay, and likewise, this element down here is the second row, second column. So we're looking at the second row of this matrix and the second column of this matrix. So 3 times 2, 12 times 3, and 1 times 5. And I'm going to add them all together. Okay, now just do a little bit of simplification. This is going to be 32. This one is going to be 34. This one is going to be 26. And this one is going to be 47. Okay, and there we are, people. That is the resulting matrix. Okay, now, for your own exercise, which you might like to try at home, what happens if we flip these two numbers together? I can tell you they're not going to be the same. Okay, I can show you they're not going to be the same, but I think it would just be a waste of your time. If I do this number, this matrix multiplied by this matrix, so in other words, do these round the other way, it would result in a different matrix. In actual fact, it would result in a different matrix dimension, because if I did it round the other way, I would be ending up with this matrix, which is a 3 by 2, and I'd be multiplying it by this matrix, which is 2 by 3. So the resulting matrix, these two numbers match, so I can do the matrix multiplication. The resulting matrix will be given by 3 by 3. Okay, so in other words, what I'm trying to say is if we have a matrix A and we multiply it by a matrix B, now in matrix multiplication they're just letters, we represent them by letters. We don't have to write the little multiply like we do in ordinary numbers. It's just like an ordinary algebra. That's why it's sometimes called matrix algebra. Okay, you don't have to write the multiply sign in here. Okay, but that is not the same as B times A. So if I flip these two numbers round, then, or flip these two matrices round, sorry, it's not a number, it's a matrix. If I flip these two matrices round, it's not the same, and multiply it's not the same. Okay. So now the next step which we look at is this thing called division. Now division is a whole different ballgame, and I'm actually going to do it in another video. Okay, this is just really the basics, and just sort of building up this idea of what addition, subtraction, and multiplication of matrices are. But division, you'll actually find out that you can't really do division of matrices.